Before we get into Unit 11, Lesson 4, Trig equations, let's first do a quick review, because it might have been a little while since you've looked at your trig. So, you've got some items that you can cut out and put into a notebook so that you have an interactive math notebook. First up, you have the quotient identities. You can cut out this snowman-looking shape, glue the flap into your journal, and then fold it on these dotted lines so that you can extend it, or not, whatever you prefer. So, quotient identities. These are things that a trig function is equal to the division of two others. The ones notable here are tangent, because tangent is equal to sine theta divided by cosine theta, and its reciprocal, which is cotangent. Cotangent is cosine divided by sine. It's important to know these because when we're simplifying things, you sometimes want to go to the division or to the single. It all depends. The Pythagorean identities. Now these, there's 3 of them. And again, you can cut out this zigzaggy shape to put into your notebook. And the first one is your sine squared plus cosine squared is equal to 1. That's the one that you have to memorize. The other two you can get to by doing things like, well, if I divide everybody by sine squared, okay, do s squared and s squared, okay, or I could just as easily do it divided by cosine. I can get the other 2. So you only need to memorize this one. To get here, I divide everybody through by cosine squared. Sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. So I can derive the second one from the first one. Likewise, if I were to go through and divide everybody by sine squared, I would get 1 plus cotangent squared plus is equal to cosecant squared. Okay, I'm not just sure why this is CO. It should just be C, S, C. Okay, questions there? Make sure you ask. These are just the identities. You need to know them. You have to know these 2. You have to know this one, and you must be able to derive the second 2. Now, opposite angle identities. Here's a unit circle. And if this is angle A, put a A, all right? So if this is angle A, then this is angle negative A. And we'll even make him blue so that we know what we're talking about. And when you're looking at things, sometimes it helps when it's color coordinated. So we have angle A. Well, if this is the unit circle, meaning that the hypotenuse, okay, or the radius is equal to 1, then the x-coordinate is the cosine of A and the y-coordinate is the sine of A. If I come down here, remember your rectangle families, okay? So if I come down here, I can actually do this. Down here, this has got the exact same x value, but the y value is simply the opposite. So therefore, down here, this is also cosine A, but it's negative sine A, which is the same thing as cosine of negative A and sine of negative A. So here is where you are getting your opposite angle identities is right here. This is essentially the proof or the drawing of it. So you just know that cosine of a negative angle is the same thing as the cosine of that angle, whereas the sine of a negative angle is equal to the negative sine of the angle. Okay? Again, opposite angle identities. Here's a picture that explains it. You should know these You can draw this in your notebook so you understand. Next up, finding the value of a trig function. How do I do that? Well, if I know that secant theta is equal to -2 and 180 degrees is less than theta is less than 270 degrees, I want to find tangent. Let's see here. Things that I know. Look for the trig identity that shows a relationship between the two trigonometrics. So here, tangent squared plus 1 is equal to secant squared. Tangent and secant are related by the Pythagorean identity. Okay? I also can look at this, and before I start doing any solving, I can note that 180 to 270 means that I'm in quadrant 3. And in quadrant 3, I can think about, is tangent positive or is tangent negative? Okay? Now, I'm going to substitute my values. I know -2, so I'm going to put the -2 in for the secant squared. And I get tangent squared plus 1 is equal to the quantity -2 squared. Tangent squared plus 1 is equal to 4. Tangent squared is equal to 3, so it's equal to the square root of 3. How do I know that it's positive root 3 and not negative root 3? Because quadrant 3, okay? Tangent is positive in quadrant 3. Therefore, I only use the positive square root. Right? And again, you can do this with any of these. So if you get secant, if you get cosine, okay, it all depends on which one you get and which identity you want to use. So this is just an example. Okay? Lots of other examples. Now, expressing values as trigonometric functions of an angle in quadrant 1. Remember that quadrant 1 is your reference angle. So the first thing you want to do is rewrite the angle as a multiple of 180 or pi plus any remainder. Pretty much most of the time in this class, unless you're working with triangles and doing loft sines and cosines, you're going to be working with radians. So if I give you something like sine of 31 pi divided by 6, that's equal to sine 5 pi plus 1 pi over 6. 6 will go into 31 5 times with 1 left over. So I simply rewrite the 31 pi over 6 as 5 pi plus pi over 6. Then I can look at my unit circle. And right here, step 2, I'm just saying if the multiple used in step 1 is even, start on the positive x-axis, else start on the negative x-axis. Because if I look at 5 pi, I go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Odds always end on the negative side, evens always end on the positive side. So I can use that knowledge so I don't have to go loop-de-loop-de-loop-de around. Now, once I start here, if the remainder is less than half of 180 or half of pi, which 1 pi over 6 is less than a half, I'm going to go in the next quadrant. Okay, so I'm in quadrant 3. If this had been 5 pi over 6, I would have jumped to quadrant 4. But it's 1 pi, so I'm in quadrant 3. So now I know that 31 pi over 6 is a quadrant 3 angle. I also know that my answer is going to be negative because sine is negative in the 3rd quadrant. Pi over 6 is the measure from the x-axis to the angle. So it is my 1st quadrant reference. It is the pi over 6 family. Theta is in Q3 and sine is negative in Q3. So I can simply come over here to pi over 6. I can get the value of sine, which is 1/2, and I know that my answer is going to be negative 1/2 because sine of 31 pi over 6 is equal to the negative sine of pi over 6. Right? Again, these are just things that you think about in your head. You can do them in a multitude of different orders. Okay, you can figure out your quadrant and the positive negative first, or you can figure out your family member first and then decide if it's positive negative. This is just one set of steps. All right? Now, this, along with the inverse trig functions, will allow you to solve basic trig functions. Let's get going on your lesson. So from this video, you're going to go on to the lesson 4 video that is simply solving trig equations.